Welcome to our podcast series, and in this podcast we're going to be focusing on system technologies. This will involve a discussion about questions related to hardware and software in computing. These topics are from question 4 of the 2024 Computer Applications Technology November exam, and there are 3 ways I suggest that you can engage with the content from this podcast. Option number 1 is if you want to test your knowledge, then first download the questions covered in the video. There is a link to a PDF in the video description below. Then I would attempt the questions in that document and then come back and listen to the discussed answers and then compare them with your answers. Another way to engage in the content is to use option 2 if you want to use the podcast to learn new information. Then listen to the discussion first. Then download the questions from the document that we mentioned earlier and then test yourself to see how much you remember from the discussion. And then our third option is to simply enjoy the discussion by listening to it and learning more about systems technologies. And now let's hear what our podcasters have to say on systems technologies.
Ever felt that moment of just pure frustration, staring at your computer screen, trying desperately to get something to work? Or maybe you've just looked at your phone and wondered, what incredible magic is actually humming inside? That feeling, whether it's a tech mystery or just sheer curiosity, is exactly why we're here. Welcome to the Deep Dive. Today we're kind of on a mission. We want to unpack some fundamental concepts in computer hardware and software, things that are absolutely crucial if you're studying computers. Think of it as a shortcut to being, incredibly well-informed, not just theory, but the practical stuff that helps you understand and maybe even troubleshoot the tech all around you.
Yeah, and what's really fascinating, I think, about today's deep dive is how we're going to connect the dots. Connect your everyday interactions with computers to the underlying principles that make it all possible. We'll explore not just what these core concepts are, but really why they matter, especially for you as you get deeper into the world of computing. Our insights today are carefully curated from system technologies, questions and answers about hardware and software in computing. It's a great resource, really distills complex ideas into those easily digestible nuggets you can actually use.
Okay, brilliant. Let's dive right in then. Something almost everyone uses. The wireless mouse. I mean, on the surface, they offer so much freedom, don't they? No tangled wires, you can lean back. But what are some of the potential headaches, the hidden disadvantages that might surprise us?
You're absolutely right. The convenience is, it's hard to beat. But it definitely comes with its own set of, let's say, considerations. One immediate thing is just how easily they can get lost. Or, unfortunately, stolen because they're so portable. They're small, light, easy to just toss in a bag and forget about.
Right.
Another big one for users is battery life. Those batteries need replacing, sometimes quite often. And that's not just inconvenient if it dies, mid-task. It can actually add up cost-wise, too.
Oh, yeah, definitely. Always seems to happen at the worst time.
And then there's the whole connectivity issue. They can be prone to signal interference or disturbance, which can make your mouse feel sluggish or jumpy or just unresponsive. Think about like a crowded Wi-Fi environment or lots of Bluetooth devices around.
Oh, I've definitely felt that lag. It's incredibly frustrating when you're trying to click something small or you're in a game. And you mentioned portability leading to small parts. What about that tiny little USB receiver thingy some of them use?
Yes, the dongle. That's a classic point of failure. That small Bluetooth or wireless receiver, it can be so easily lost or even damaged. And without that specific little piece, or if you just walk too far away from it, the mouse is completely useless. It's kind of a prime example of how modern tech sometimes trades that simplicity for these complex dependencies, that tiny receiver. It's a single point of failure that can just stop you in your tracks.
That's a really good point, keeping track of all those tiny, crucial bits. Okay, so speaking of keeping things working and secure, let's talk security. We're all trying to keep our devices safe. But what if the most secure key wasn't something you remembered, but something you are? Tell us, what exactly is biometric security? How does that work?
Right, biometric security. It's basically using your unique biological features, things that are part of you, to access devices or systems.
Yeah.
It's a very personal form of authentication. Instead of a password you type, it uses something inherent to you, like a key only you have.
Okay, like fingerprints.
Exactly. Fingerprint readers are a really common example, scanning the unique wrenches on your finger. Then you have iris or retinal scanners, mapping the patterns in your eye, incredibly precise stuff. Facial recognition cameras use your unique facial structure. and even voice recognition microphones, analyzing your specific voice patterns.
Wow.
And this approach really matters because, well, two main reasons. One, it offers enhanced security. Your biological features are super hard to copy. And two, amazing convenience. Often it means quick, seamless access without typing anything.
That's pretty cool, using your own body as the password. No more forgetting complex ones. Okay, shifting gears a bit. Ever been right in the middle of a big project, maybe coding or writing a crucial essay for school, and bam, the power just quits. All that work potentially gone. There's a piece of tech designed exactly for that, right? What's the purpose of a UPS compared to just, the standard power supply in the computer?
Ah, the UPS. A lifesaver, truly. And yes, it's a critical distinction. Your standard permanent power supply, the box inside your computer, its job is to take power from the wall and convert it, providing continuous power while the electricity is on, stable power. But a UPS, an uninterruptible power supply, has a completely different, almost superhero role.
Okay.
Its main job is providing backup power during an outage. It has a battery inside. So if the main power cuts out, the UPS instantly kicks in. It gives you a temporary power source.
So it buys you time to save everything.
Exactly. It buys you precious minutes. And crucially, a UPS also protects your devices against power surges, those sudden spikes in electricity. They can seriously damage sensitive electronics. A UPS helps smooth those out.
Or I hadn't thought about surges.
But yeah, perhaps its most valuable function for you as a user is that it allows you to save your work and safely shut down your device during an outage.
Yeah.
Think of it less as just a battery, more like an intelligent bridge. It manages that transition, protects against sudden cutoffs and those fluctuations, preventing data loss and potential hardware damage. That's invaluable.
Absolutely. That ability to save your work before everything goes dark.
Yeah, that's huge. Keeps your digital life safe. And when we think about what a UPS protects, we're talking about the computer itself, the heart of it. So for someone thinking about building a PC or even just curious about what's inside their current one,
Yeah.
what are the absolute basic hardware components, the essential bits we need to know about? What makes it all tick?
Right, building blocks. And when you're looking at any end-user computer, desktop, laptop, whatever, there are core components that define what it can do. First up, the processor, or CPU. Central Processing Unit. That's basically the brain.
The brain, okay. Yeah, think of it like the conductor of an orchestra, directing everything. It processes all the instructions. Then there's memory, or RAM, random access memory. This is the computer's short-term workspace. It's where the CPU keeps data it needs to access really quickly while it's working on tasks.
So more RAM means it can juggle more things at once, basically.
Precisely. More workspace. Then you need storage. This could be a super fast SSD, a solid-state drive, or maybe a traditional hard disk drive, an HDD. This is for long-term saving your files, your programs, the operating system itself. That's like the filing cabinet.
Gotcha. Brain workspace filing cabinet.
Kind of. Then you have the motherboard. This is the main circuit board everything plugs into. It connects all the components so they can talk to each other. You also usually need a graphics card, or GPU, especially for gaming or video work. It handles all the visual output. A network card, or NIC, lets you connect to the internet or a network, usually built in these days. And finally, everything needs juice, so a reliable power supply unit is essential to convert wall power safely for all these components. Understanding these helps you figure out, say, what might need an upgrade if your computer feels slow.
Knowing those components is like having the blueprint. That's really helpful. Okay, now let's talk about a universal tech frustration. The no signal error on a projector. We've all been there, right? You plug it in, ready for a presentation, maybe for class, and bam. Nothing but that dreaded message. It's so frustrating. What are the usual suspects behind this? How can we troubleshoot it?
Oh yeah, the no signal demon. It is a common headache, but thankfully, the reasons are often pretty straightforward. A lot of the time, it's something simple. Like the cable, HDMI, VGA, whatever you're using isn't plugged in properly, either at the computer end or the projector end.
Okay, the classic, is it plugged in? Check.
Exactly. Always start there. Make sure they're fully seated. Sometimes the cable itself might be faulty, or maybe the port you're using is damaged. Try a different cable or port if you can.
Makes sense. Simple stuff first.
Beyond the physical connection, another frequent issue is the display settings on your computer. Your laptop might be set to extend or duplicate, or maybe second screen only. And if the projector isn't detected right for that setting, you get nothing. Check those settings, usually by pressing a function key or going into display properties.
Right, like the Windows key plus P shortcut.
That's the one on Windows, yeah. Also, simple thing, but is the computer actually on? Or is it maybe asleep? Happens more often than you'd think.
Guilty is charged on that one before.
Less common, but possible. are faulty or outdated display drivers on your computer. Might need an update. And finally, check the projector itself. It probably has multiple inputs, HDMI 1, HDMI 2, VGA, PC, etc. You need to make sure the projector is set to the source you actually plugged your cable into. There's usually an input or source button on the projector or the remote.
Ah, the source button. I spent ages once fiddling with cables only to realize that was the problem. Knowing these steps is super practical, can save a lot of stress. Okay, let's shift focus a bit to something really important. Making tech work for everyone. Accessibility. Technology should be inclusive, right? So, how can computers be made more accessible, specifically for someone who is deaf?
Absolutely. Inclusive design is crucial. And for someone who is deaf, computers offer some fantastic features to bridge communication gaps. The most obvious and widely used are captions and subtitles for anything with spoken dialogue. Videos, meetings, presentations makes a huge difference.
Yeah, captions are everywhere now, thankfully.
Then there's speech-to-text functionality. This can convert spoken words into written text in real time. Super useful for live conversations, or maybe getting a transcript of a lecture. And think about sounds the computer makes alerts, notifications. These can be missed. So technology can provide visual notifications, like flashing the screen or a specific light, or even motion or vibration notifications, maybe through a connected device, giving a tactile cue instead of an audio one. It's all about providing equivalent alternatives.
It's amazing how tech can adapt like that, making the digital world genuinely more inclusive. That's great. Now let's talk about the manager of your computer. The operating system. It's like the conductor, managing programs, users, everything. One big job is managing users. What's the core difference between a single user system and a multi-user system?
Right. This is pretty fundamental to how the OS is designed. A single user system is, well, like it sounds. It's limited to only one active user at a time. Think about your personal laptop. You might have different accounts, maybe for family members, but only one person is logged in and using it actively at any given moment.
Okay, that makes sense.
In contrast, a multi-user system is built to allow more than one user to access and use the system simultaneously, concurrently. They could be working on completely different things, but they're all logged in and interacting with the same core operating system environment at the same time.
Okay, so where would we actually see these multi-user systems in action? Because like you said, most of our personal devices feel single user.
That's a great question. Multi-user systems are actually everywhere, once you look beyond just your own PC. They're very common in online gaming. Think about hundreds or thousands of players connected to a game server, that server's running a multi-user OS managing all those connections.
Oh, okay, yeah.
Also, think about big online platforms, social media, streaming services, collaborative tools like Google Docs, countless users hitting the same system at once. And critically, they're essential for networked companies or institutions, like your school network or university or banks. In those places, loads of people need to access shared resources, databases, applications, all managed by a central multi-user system. They enable huge efficiency and collaboration.
Right, that makes total sense. Now let's talk about the look and feel, the graphical user interface, the GUI. It's our window to the digital world, all the icons, menus, windows we interact with. But it's not set in stone, is it? How can you actually make it your own? Customize it to suit your preferences, make it feel more like your space?
Well, yeah, customizing the GUI is all about making your experience better, more comfortable, and often more productive, too. There are tons of ways you can tweak the display or visual settings, adjust screen resolution for clarity, change the background wallpaper to something you like, apply whole themes that change colors and icons.
Like dark mode.
Exactly. Dark mode is a popular theme choice. Or just adjusting screen brightness. Then there's the desktop layout. You can add shortcuts for things you use all the time, remove clutter you don't need. Basically, organize your digital desk.
Keep it tidy?
Precisely. You can also change input or device settings. Maybe customize keyboard shortcuts for faster actions, or change the size or even the shape of your mouse cursor to make it easier to see. Sound settings, too, change those default system bloops and bloops to something else, or adjust notification sounds, and even system preferences like changing the date and time format or deciding which little icons show up in your notification area. All these little tweaks add up to make your computer feel more personal and efficient for you.
It really is about making the tech work for you, not the other way around.
That's cool.
Okay, now for something less cool. Software bugs. Let's face it, no software is perfect. We often run into flawed or faulty software that just doesn't work right. What can we as users actually do to fix a software bug when we find one?
Right. Bugs are unfortunately a fact of life in software. When you hit one, there are a few standard things you can try. The most common fix is to install a patch. Developers release patches specifically to fix known bugs or security issues. It's like a small software bandage.
Okay, patch.
For bigger sets of fixes, maybe including some new features or performance tweaks too, developers might release a service pack. It bundles up lots of patches and updates together. And generally, just updating your software to the latest version is often the best first step. Developers are constantly fixing bugs, so the newest version likely has fixes for issues found in older ones. Keeping things updated is really key.
That makes sense. Always clicking update later. Maybe I should stop doing that. But what are the actual risks then? If you don't fix these bugs, if you just keep running flawed or outdated software, what's the real danger beyond just being annoying?
The risks are actually pretty significant, and they go way beyond annoyance. It can impact your security, your data, your whole system. The biggest risk is security vulnerabilities. Bugs can create accidental backdoors, security loopholes that hackers or malware can exploit to get unauthorized access to your computer or steal your information.
Wow, okay. That's serious.
Definitely. Another major concern is data loss or corruption. A bug could cause the software to crash while you're saving, or mess up a file, leading to you losing important work or personal data. Related to that, buggy software can just make your whole system crash more often. Freezes, blue screens, constant disruptions. And finally, you can run into compatibility issues. Flawed software might not play nicely with other programs or even your hardware, causing more errors or slowdowns. So yeah, those updates, they're not just for new features, they're vital for keeping your system secure and stable.
That really hits home why updates matter. It's basic digital hygiene, really.
Okay, speaking of keeping things safe, let's talk file protection.
There's a subtle difference between making a file hidden and making it read-only. Why might using the hidden attribute actually be better sometimes for protecting data compared to just read-only?
That's a good distinction to understand, and it really comes down to visibility versus modification permission. When you set a file's attribute to hidden by default, it just doesn't show up in your normal File Explorer view. You can't see it without changing specific folder options. So it makes it much harder for someone to accidentally find it, delete it, or even know it's there. It's sort of tucked away.
Out of sight, out of mind.
Exactly. Whereas a read-only file is perfectly visible. You can see in the folder list just fine. The only restriction is that you can't easily change its content or delete it without consciously removing the read-only flag first. So read-only prevents accidental edits, but it doesn't prevent discovery.
So hidden is better if you don't want someone to even know the file exists easily, while read-only is more for preventing accidental changes to something people can see.
Precisely. If the goal is obscurity, making it less likely someone stumbles upon it, hidden offers better protection just by removing it from plain sight. You might use read-only for important system files you shouldn't tamper with, or a template you want people to copy but not overwrite. Hidden might be for, say, configuration files, or maybe stuff you just want kept private from casual browsing.
That's a really useful practical tip for file management. Good to know the difference. Okay, finally, let's tackle one last thing. That utility feature you sometimes see, especially maybe on older systems, optimize and defragment drive. What does that actually do, and why would a user ever need to use it? Sounds a bit technical.
Right, defragmentation. It sounds technical, but the concept is actually pretty simple, especially for traditional spinning hard disk drives, HDDs. It's less of a thing for modern SSDs, by the way. Imagine your hard drive is like a big library bookshelf. When you save a file, especially a large one, the computer might not find one continuous empty space for the whole thing. So it breaks the file into pieces and puts those pieces in different empty spots all over the shelf. That's fragmentation. Your file is scattered.
Okay, like a book scattered across different shelves.
Exactly. And when you want to read that file, the hard drive's RAID head has to physically jump around to all those different spots to collect the pieces. That takes time, slows things down. So the purpose of defragmentation is to reorganize that fragmented, scattered data. It picks up all the pieces of each file and puts them back together in nice, continuous blocks on the drive. The goal is purely to improve performance and efficiency, make reading files faster because the drive head doesn't have to jump around so much. Sometimes it can also help sort out minor disk errors in the process. But mostly, it's about speed, making your system feel more responsive, especially noticeable on older machines with HDDs.
So it's basically tidying up your digital bookshelf to make things run faster.
That's a great analogy. Wow, we've really covered a lot today. From the unexpected quirks of wireless mice and the coolness of biometric security, to the unsung hero that is the UPS and the actual building blocks inside your computer. We even tackled those super frustrating no-signal errors explored making tech accessible for everyone, understood operating systems a bit better, and learned how to customize our digital space. Plus, those crucial tips on software bugs and file protection, and finally, optimizing drives. These aren't just random facts, are they? They're all connected pieces, helping build a real understanding of how computers work and how we can work with them better. Absolutely. And if we connect this to the bigger picture, understanding these foundational concepts, it isn't just about passing a test or fixing a small problem. It's really about becoming more confident, more capable in a world that's, well, increasingly built on technology. And that kind of raises an important question for you, the listener. How will you use this deeper understanding maybe to build something new or troubleshoot the tech of tomorrow?
That's a great thought to end on. Thank you so much for joining us on this deep dive into essential tech for high school computer science. We really hope you feel a little more informed, maybe even inspired to, tinker a bit and apply what you've learned. Until next time, keep exploring, keep learning, and keep diving deep.
If you found the following podcast useful, then please subscribe to the channel, support us, and make sure that you don't miss a notification when we post new information. We're also on TikTok at Mr. Long Education, and remember our other channel at Mr. Long IT and Cat. And remember, don't do it the long way, do it the Mr. Long way.